Welcome to this course OC MBA 112 Business Data Analysis for Management Science, Week 4, Lecture 4, Regression Equation of Y on X by Dr. K. Sankar Singh.
In this lecture session, we are going to discuss the introductory part of the regression. What are the two different types of regression equations? Then finally, we are going to discuss how to construct the regression equation of Y on X with the numerical problem. Okay, in the introductory part, the correlation coefficient is a useful statistical tool for describing the type and the intensity of linear relationship between the two variables. But it fails to give a mathematical functional relationship for prediction purposes. Regression analysis is a vital statistical method for obtaining functional relationship between a dependent variable and one or more independent variables. More specifically, regression analysis helps one to understand how the typical value of the dependent variable changes when any one of the independent variables is varied, while the other independent variables are held fixed. It helps to determine the impact of changes in the values of the independent variables upon changes in the value of the dependent variable. Regression analysis is widely used for prediction. Regression equation is widely used for prediction. The two regression lines coincide when there is a perfect positive or perfect negative correlation between the two variables. If there is zero correlation between two variables, that is, if the variables are uncorrelated, then the two regression lines are perpendicular to each other. These regression lines are expressed algebraically as regression equations, namely regression equations of x on y and y on x. Let us consider two variables x and y. We shall have regression lines, one regression line of x on y which gives the most probable values of x for given values of y, and another regression line of y on x which gives the most probable values of y for given values of x. Thus, in the case of two variables x and y, we have two regression line, one to estimate x given y and another to estimate y given x. So what is the formula for constructing the regression equation of y on x? So the regression equation of y on x is y minus y bar is equal to byx into x minus x bar. Here x bar, y bar and byx, what are they? They are all statistical constants. So x bar equal to arithmetic mean of x, y bar equal to arithmetic mean of y, byx is equal to regression coefficient of x on y. So x bar equal to formula sum of x divided by small n. Similarly, y bar equal to sum of y divided by n. And byx, regression coefficient of y on x formula is n into summation xy minus summation x into summation y whole divided by, in the denominator, n into summation x square minus summation x the whole square. This is the regression equation of y on x. Now we are going to construct the regression equation of y on x with the numerical example. So here we consider one numerical problem. Calculate the regression equation of y on x for the following details. Here pairs of observation here given. So x equal to advertisement expenditure rupees in lakhs, and the respective Y value is sales rupees in crores. These are the given pairs of observation. For this data, we have to construct the regression equation of Y on X. For this, we consider let X be the advertisement expenditure and Y be the sales. Before construct the network diagram, we need to calculate X bar, Y bar and BYX. For this calculation of statistical constants, we need to construct a table with 5 columns. What are they? The first column is X, second column Y, third column X square, fourth column Y square and the last column XY. X and Y, the given pairs of observation, we simply substitute in the X and Y column. Then third column is X square, we square all the X values. Similarly, fourth column Y square, we squaring all the Y values. XY, XY is the product term of X and Y. Finally, from this table, we have to calculate the total for all the 5 columns. So, like X total is 87, Y total is 36, X square total is 1769, Y square total is 274 and XY total is 682. So we got the summation of X, summation of Y, summation of X square, summation of Y square and the summation of XY. After that, here n equal to the number of pairs of observation 5. So X bar is arithmetic mean of X, formula sum of X divided by small n. Here X total is 87 divided by 5, that is equal to 17.4. Similarly, Y bar equal to arithmetic mean of Y. Here the formula is summation Y divided by small n, that is equal to 36. Y total is 36 divided by 5, so that is equal to 7.2. And BYX is equal to regression coefficient of Y on X. The formula is n into summation xy minus summation x into summation y whole divided by, in the denominator term, n into summation x square minus summation x the whole square. So we substitute all the totals like xy total, x total, y total, x square total and x total the whole square. All the terms we can simply substitute in this above formula. Finally, we got the regression coefficient of y on x value BYX equal to 0.22. So far we calculated x bar value 17.4, y bar value 7.2 and BYX value 0.22. Finally, we substitute in the regression equation of y on x. The formula is y minus y bar equal to BYX into x minus x bar. Now, we substitute y bar value, BYX value and x bar value in the above equation except x and y. After that, we simplify the regression equation of y on x. Finally, we got this equation like y equal to 0.22x plus 3.37. This is the regression equation of y on x for the given pairs of observation. Thank you.